So the slides do include video. I'm going to attempt to play the video via Zoom. That may or may not work so well, but you can always download the slides later and watch the videos on your own time. Okay, let me get started. So let me organize things a bit more here. Okay. Sorry, I'm just moving things around. Not in the way. All right. So welcome to the Web of Things breakout session. The purpose of the Web of Things is to apply web technology to IoT use cases, Internet of Things. So basically enabling devices to interact on the internet and as web services and with web services. And so our major goals is to achieve interoperability. IoT has a serious problem in that there's lots of narrow verticals, and it's very hard to combine things together to create new applications because everyone has their own standards. There's too many ways of doing things. And so we wanted to figure out how to bridge these silos to enable mashups. And in particular, we're also working on things like a scripting API to allow you to glue things together. And I'll show several examples of that. We also wanted to simplify ingestion of data. So if you get data from an IoT device, we'll make it easy to import that information into a database or into some analysis service. And generally, we'll make it easier to use IoT devices. Now, we're in our second charter. In our first charter, we published two documents, an architecture document and a thing description, and also some informative documents for security and for scripting. We are updating those documents, and we also have several new documents. We're working on some use cases. We're working on new normative documents for discovery and for profiles. Now, I'll just describe briefly our main deliverable so far, which is a thing description. So a thing description is a JSON LD document, which formally describes a device, including metadata about the device, like a description and an ID number and so forth, and also what its network interface looks like, what kind of security information is needed to access it, what the interactions are, what the protocols are used for those interactions, what the data looks like that is retrieved by the device, what the content encoding is, and so forth. Because it is JSON LD, JSON linked data, it supports the semantic web, and it supports semantic annotation. So we've also been coordinating with other activities like One Data Model to allow use of semantic annotation for IoT and for other things in thing descriptions. I should also say the data schemas that are embedded inside thing descriptions to describe the data returned by IoT devices is based on JSON schema, although you can also have other kinds of structured content like CBOR or XML described with the same schemas. Now, our new work items include use cases, and we actually have a large catalog of use cases, and we've been doing a lot of work to identify requirements and gaps and overlaps with other groups, for example, geospatial information. Our architecture, we're also going through and adding information about life cycles and requirements analysis based on the use cases. The two, however, major new normative documents are discovery and profiles. So TDs describe metadata about devices. It doesn't say how you get the TD for a device. So discovery is about how those TDs are distributed, both locally and globally. So it's not just local network discovery. It actually includes things like search on the internet, including geospatial search. We have a strong emphasis on privacy protection. So in particular, we're using a two-phase approach. The first phase is open and uses a variety of existing discovery protocols as a first contact mechanism, but does not distribute metadata. Then after authorization, then you get an exploration phase where you actually get access to thing descriptions. So the idea here is we have a very minimal cross-section as a first contact protocol, and then you authenticate, and then you get access to metadata. We also protect queries so that the query itself, first contact query is very simple, and the detailed queries are only after authentication. Profiles are about limiting the choices available in the thing description. So right now, thing descriptions are very open-ended. You can have arbitrary content types and arbitrary protocols. The trouble is, if you want to implement a device and know in advance that will work with other devices, you have to have a finite set of protocols that are supported so that you have a finite code base for the device. And so this requires, a set of constraints defined on thing descriptions for what protocols are supported. So profiles are about defining these sort of constrained subsets of thing descriptions. Now, we've been doing a lot of work on implementations and on tools. So in particular, we have a implementation of our scripting API, which simplifies the use of thing descriptions from Node.js, and is an implementation of our scripting API. This is an open source project called NodeWatt under the Eclipse Foundation. We also have a lot of work done, and especially by Hitachi, on the integration of thing descriptions with Node-RED, which is this visual language you can see over here on the right top. Basically, a boxes and arrows approach to programming IoT orchestration. And I'll again give some demonstrations of that. And we're integrating both of these with discovery mechanisms. And finally, we have some work, again, another open source project on a validation tool that allows you to take a thing description and check that it's correct. And that validation tool can be run either as a web service or simply as a Node.js script application. Now, in the past, we have run many in-person plugfests where we all brought our devices and try to get them to all work together. And the last TPAC, we brought several devices, many devices, and had them interoperate. We also had a workshop in Munich last year. However, given COVID, we haven't been able to, of course, meet in person. So we have shifted the last 2 times to online plugfests. However, we've still accomplished quite a lot using remote access to devices. However, I just want to summarize on this slide, you actually see several things. So up in the top left are 2 images from TPAC last year. We're looking at some home automation applications. On the bottom left, you see an example of HybridCast from NHK, which I will talk about in a minute. In the upper right, you will see an application from Oracle using digital twins and actually using remote access to actually a pump simulation. And in the middle, you see a factory simulation that's put together by Siemens. So, and there's many more things that have been done at these plugfests. Now I'm going to talk about a few things we did in our very last plugfest, which was an online plugfest held this October, so just before TPAC. So, one we did here is Bologna University has been, and actually Technical University of Munich, have both been using Watt to teach IoT to students. And they put together some environments for doing teaching. So Bologna had a simulated farm that was used to simulate IoT devices and allow people to write scripts to control them. And TUM had physical devices that they set up for their lab. They made available to students for doing projects. And during the online plugfest, we connected these over the internet and built some mashups combining both of them. And so there's a little video that kind of walks through both of these, walks through the farm simulation and shows a mashup with things from Tom. So the farm simulation is quite interesting because it combines several aspects that are relevant to many use cases. It includes actuators, output devices. It includes sensors, input devices. It includes actions. It includes event notifications. It includes geospatial information. So all these things come together in agriculture. These same things, of course, also show up in other applications, such as smart city, smart home, vehicle and logistics, transportation, and so forth. So this is, of course, not limited to agriculture, but this just happens to be a useful use case to explore and to teach people IoT. I'm going to go ahead and play this video. And this video is available online as well. There's a link.
Hello, welcome to this video. I'm Cristiano, and I will show you one of the outputs of this October 2020 online plugfest. So in this plugfest, we designed different test scenarios. One of those was to synchronize smart agriculture application built with the Web of Things technologies in mind. You can find more in the description below. On the other end, we have a SenseHat device hosted at the remote IoT lab of TUM Institute. The SenseHat is an add-on board for Raspberry Pi which features a set of sensors and a 8x8 multicolor LED matrix. Today, we'll control this matrix for our application. If you want to know more, use the link section as well. Notice that those devices were not meant to work together. On the contrary, they were designed for different applications with different goals. Our purpose today is to create a Mashup application that turns on a section of the sensor display for each virtual sprinkle. But let me explain. We have 4 different sprinkles inside the WAF farm. They can be active or not. So we divide the display in 4 sections and color them with 4 different colors. Consequently, if a sprinkle turns on, we also light up the corresponding LED matrix section. So this is the application. Let's give a look at the code. So here we are. We have the short script with just 30 lines of codes, plus this little LED matrix class, which is an utility class used to handle the state of the LED matrix itself. In fact, we have 2 methods over here, one for setting the phase status on and off, basically, using the color defined over here, and an utility to array method, which basically turns the matrix to an array. Because if you have a look to the SenseHat thing description, you can find that the pixel property is actually an array composed by exactly 64 elements, and each element is an array of exactly 3 elements that goes from 0 to 255, which is basically the range, the RGB range. Okay, and now let's see the output. Let's see if it's working, basically. So let's minimize this, open the WAF farm, provided link. While it's loading, I open also the stream, live stream from TUM Institute. Yes, there we are. We are going to use this Raspberry Pi and the SenseHat display, the second one. I hope you can see it. And here we have our 4 sprinkles. One here, and one here. Yeah, this is sprinkle 0, for example. So let's start. I use this REST API tester to start the action, start sprinkle, but you can use whatever client you want. Even CURL is okay. So let's start sprinkle 0. Okay, started, and also the corresponding section of the LED matrix display is on. Now let's do also sprinkle 2. Okay, it's on, and also the LED matrix is on. 1, 3. So you can see the whole LED matrix is on, and every single sprinkle is on. Okay, and now let's stop each one of them. Stop action here. Stop, for example, sprinkle 1. Yeah, it's down. Try sprinkle 3. It's also down. Then sprinkle 0, which is the upper right. Yes, and finally, which one this was? Oh, let's see, sprinkle 2. And sprinkle 2. Done. So that's all. I hope you enjoyed. See you in the next video. Thanks.
Yeah, and just to point out some things here. So students might, of course, do more sophisticated things. They might create a web interface with a dashboard showing the locations of the sprinklers and providing a web interface. They might connect to web services. There are sensors on the field that give the moisture and temperature content. And so they might build applications that optimize the watering of plants. They might connect to a web service, giving them the weather, and then plan out a watering schedule that minimizes the use of external water and doesn't overwater plants and so forth. So this is actually a very interesting environment because it gives them all kinds of opportunities to experiment with applications using IoT combined with web UIs and web services. Now, moving along, I can convince us to go to the next slide. Right, so let me talk about another thing that was worked on. So not everyone wants to write scripts. There are lots of applications where the users do not know programming. And so in particular, in agriculture, maybe it's a farmer that wants to set up their farm. Maybe they're not a programmer, which is probably likely. So in that case, maybe they want to use something else like a visual language, and Node-RED is just such an application. However, we don't even want people to have to deal with thing descriptions or JSON or any of that stuff. And so how can people do applications at a very high level without having to get down to the weeds of looking at JSON or writing scripts? So Hitachi worked on an auto population system. And the basic idea here is that we can use discovery to find devices. We can automatically retrieve their thing descriptions. We can then populate a catalog and allow Node-RED using the user interface, a graphical user interface, to install nodes representing those devices in a Node-RED graph. So we've got a video for that as well. Now, I'm going to play this video, actually, and you'll note that it's actually very quickly, so we can build an application without ever looking at a thing description or writing any code. Is it playing? So what they're doing is they're clicking the refresh button. That triggers discovery. So now they've found a bunch of devices. They're going to select a device, which is a hybrid cast emulator, actually, and they're going to install it. So that is going to pull down and generate a Node-RED device and add it to the palette. So when they close this, it will be adding it to the palette, as you can see here. And now there's a new block over there, and they can drag and drop into a graph. They can wire it up with existing devices or other devices. So lots of the different devices could be existing here, as well as things like functions and other kinds of things they could add. And it might also be descriptive information from the thing description showing up here, explaining how to use it, and boom, we're done. So without doing any code, right, just dragging and dropping and clicking things on the GUI, you can set up an orchestration for IoT devices. And in fact, can connect any device described by a thing description. Okay. So I think this is, extremely valuable, and we have shown this to people in retail as well, and they are very excited about the possibility of using this by, for example, a store manager in a store. Okay, so that's Node-RED, and to be clear, this also actually has accessibility applications, because you could, for example, control your television channel using some IoT device to select the channel. And by wiring up something like this, you can connect an input device, an arbitrary input device, to control an arbitrary other device like a TV set. Which brings us to this application. So NHK did some work where they are broadcasting data along with their HDTV programs. And actually on that picture there, you can see an example of some data coming through from a program. And this data can be used in various ways. You might, for example, broadcast the desired temperature or color of the room, or the loudness of the speakers. And then you could use that to connect to other IoT devices. You could also use hypercast information to select channels, and also to launch applications which do various things. And so what we did during the plugfest is we've already seen the DNS-based discovery. I'm going to show you a couple more scenarios using hybrid cast and television control, media control. So scenario one is simply controlling the channel in the television set and looking at the status of the TV. This is really simple, but it gets very interesting when you consider that you may have a disabled person needing to have an alternative input device to control the television set. And so this makes it very easy to build arbitrary devices to enhance accessibility. Scenario two is events broadcast by television can be used to trigger events in IoT devices. Now, the scenario is given as very simple, but you can imagine this being used for things like typhoon alerts or earthquake alerts. You could broadcast information about that, and you could trigger an IoT device to indicate to somebody that there's an incoming earthquake or whatever. So, so that kind of stuff can also be supported. So here's the first scenario, just controlling a channel. So first of all, you can get the channels that are available from the receiver. You can get the current status of the TV, is it on? Is it using hybridcast? And then you can send a command to the television to select a channel. You could also select instead a hybridcast application. So for example, you might launch a weather app or a news app. These controls may also be driven by maybe input and output devices too. So maybe you launch the weather app when someone enters the room, right, with an infrared sensor. Or maybe if there's new news, you could blink an LED with an output device. Okay. Scenario two is we're going to control some other devices. So here we have, we're listening for events, and this would listen for a particular event. In this case, we're watching, a cooking show, or, maybe it's a Coffee with Susan. And so when we log into the show, it's going to trigger our coffee machine to make a latte. So we can all have coffee together. And so this is broadcasting, make some coffee, and maybe even broadcasting information about a particular recipe for the coffee, and then triggering a coffee machine to brew some coffee. And so this is actually in the actual Mashup, it was an online plugfest. So it was actually a hybridcast receiver in Japan triggering coffee being made in Germany. But of course, in other cases, it could be in the same country. There's also a Hitachi LED, which is used to indicate that, this is an activity that's going on. So of course, in other situations, we just plugged together what we had, But you can imagine other use cases where you plug together various kinds of devices to do various things triggered by events in broadcast media. Okay, and this is just a little video showing that in action, and this is actually showing you the channel select and app select application. There's no audio, so I'll just speak over it. But basically, you see the television program down here, and you see this stuff. Now, there's clicking on these buttons to trigger the various actions, but in practice, you'll probably have other IoT devices providing an input control. Maybe for a disabled person, you might have a head switch and a selector that is triggering these various events. And again, the advantage of using this for accessibility is that you can customize it to the person's needs very easily by dragging and dropping. So a consultant could, within a few minutes, configure a input device for that particular person. Okay, so the final thing I want to talk about is geolocation. Now, we are currently, we really need to work hard to coordinate our activities around geolocation with other groups doing geolocation. And that includes groups like the Open Geospatial Consortium and the Spatial Data on the Web group. And also we have a geolocation API in the browser that we'd like to make consistent what we do in IoT for geolocation. So we are planning probably mid-November to meet up again with Geospatial Data on the Web working group and to sort out what we have to do here. However, during the plugfest, we did prototype various approaches. And as you can see here, we built a mashup that integrated geolocation information with mapping applications. As you can imagine, for example, in agriculture, I might want to be able to map locations of my sprinklers and have a map dashboard to control location. Logistics, I might have other geolocation data that's actually changing over time, as for example, trucks make deliveries and so forth. And so in that case, I need actually dynamic data as geolocation. In fact, one of our challenges is that geolocation data could either be metadata in a TD, or it could be data delivered by a device dynamically. And so we have to figure out how to combine those two approaches and make them both work in a consistent way. So we're very happy to collaborate on this, and we want to find something that's not a reinvent the wheel, but builds on existing standards in a good way. Okay, so just to wrap up and to summarize, during our plugfest, we worked on NHK Hybridcast integration, including a mashup with devices not from NHK, from Germany, in fact. Hitachi did some great work to do Node-RED integration with our discovery work. And they also did that with NHK, did an NHK mashup too. We also did mashups between University of Bologna and TUM on this smart farm, which is also going to be a basis or foundation for lots of great tutorial and experimental work for like teaching and training IoT. We also finally did some work on geolocation and how to embed geolocation information into a TD and to visualize it on a map. So now I want to say as well, besides the plugfest, we also recently released the files for our first public working drafts of our initial documents on profiles and discovery, and for updated documents for TD and architecture. Those are currently pending and should come out next week. We also updated a note for our scripting API, an informative document. In the TD 1.1, there were some significant updates. Now, our plan is to update a backward compatible update for TD 1.1. Current spec is 1.0, and then we're releasing 1.1. The TD 1.1 includes some enhancements to security In particular, we added 2 OAuth flows for client and device, both of which are very useful for IoT because client does not necessarily require a human to participate in the key, which is very common in fully automated situations. And device supports things like device pairing when a IoT device has no display, it has no user agent. So both of those are very common in IoT scenarios. We also added a combo security scheme to handle more complicated security configurations. So particularly the combo scheme allows and or combinations of other security schemes. So for example, suppose you have a proxy and the proxy can use either basic or digest authentication. And then the proxy goes to an endpoint and the endpoint uses OAuth and allows either client or device authentication. Okay, so you actually need to do digest or basic and client or device, right? With parentheses inserted as appropriate. So, so the combo scheme allows you to express that. The other thing we did is thing models. So right now, thing descriptions describe a particular device, a particular instance of a device. But very often devices are part of a class of devices, all say manufactured with this as the same model. And so a manufacturer wanted to define a thing model which describes the entire class. And a thing model is basically a thing description, but omitting certain information like the ID number or the ID identifier of the particular device or the base URL, which are only established when the device is manufactured or installed. So thing models have 2 big use cases. One is as a developer, I need to know how to write, say, an orchestration script for a class of devices. And then when that script is installed, then it discovers things that belong to that class and then can connect to them. So I need to know the information in the model to know how to write my script, what interactions are available in that class of devices. The other application is I have a digital twin and I want to read information from a certain class of devices. So data is coming into a database I'm going to ingest. So I might have set up my database in a certain way. I need to know what the data will come in, what it will look like. And so again, the thing model provides data schemas that can tell us what that data will look like. So this is closely related to work on digital twins, and thing models are tending to support that. Now, our next steps, and this is leading into discussion. We have a lot of work going on right now on use case collection. So the Watt-use cases repo has a ton of documents there where we've been collecting use cases. I should also say one of our major use cases is the smart city. And there's a breakout on Thursday to discuss spinning up possibly a new IG just for smart cities, which will include, but is not limited to, IoT impacts in the smart city. We also, as I mentioned, we need to coordinate with spatial data on the web around geolocation standards. Scripting is basically for doing orchestration, but then the question arises, where does this script run? Running in the browser really isn't appropriate because when you close the browser, then your orchestration would stop. And what if it's running your security system for your house, right? You can't have it stop when your browser closes. So what you actually want to do is install the script into an edge computer that is always on. And so we're looking at ways to maybe enable that in collaboration with web and networks. So really, one of the places we might want to use a Watt scripting API is in an edge computer that is enabling some kind of ambient activity and is providing a new IoT service that is kind of always on. For discovery, we've been spending a lot of time thinking about how to do this while maintaining privacy, but we need to do a lot of work to get feedback and input on that to make sure that we're doing the right thing. So we certainly encourage people to take a look at that and give us feedback on whether we're aimed in the right direction with regards to privacy. And finally, profiles, we're looking at building constrained TDs. Are we adding the right constraints? Are we making TDs broad enough under profiles to still handle all the important use cases? So again, we need feedback on those profiles to make sure that they handle everything they need to handle while still being constrained enough to be implementable. Okay, so with that, I'm going to stop. And I think we probably want to pause the recording and then start answering and having discussion, answering questions and having discussion.